Let us write a C program to convert decimal number to its equivalent octal number. To do this conversion from decimal to octal, let us see the algorithm involved. As we know, decimal number consists of 9 digits 0, 1, 2, 3 till 9. Octal consists of 8 digits 0, 1, 2 till 7. As a first step, we have to divide the decimal number by 8. 8 being the number of digits that octal integer can accept, that is 0 to 7. Octal digits will be from 0 to 7, that is only 8 digits. We have to divide the decimal number by 8. The next step is the remainder that we get from step 1. After dividing by 8, if we get a remainder, we have to store it. The third step is we have to repeat the first 2 steps, that is dividing and storing the remainder, until the decimal number is 0. We will get the octal equivalent of the decimal number by reading the remainder we have received at step 2 in the reverse order. Meaning the position of the remainder we have to consider. Let us take an example here which will make us to understand easily. Let us take the decimal number 200 and then see how it can be converted to octal. So I am making 3 columns: decimal number, the divider 8 and the remainder value. So as I said, let us take 200, the decimal number for which we have to find the octal equivalent. On dividing by 8, we will have 0 remainder. And the value will be 25, which again when divided by 8, 3 times 28 gets in 25 and the remainder is 1. The 3 is not divided by 8, hence the remainder is 3. So the octal equivalent of 200 is reading the remainder in the reverse order, that is 310. So we have to read it in the reverse order from 310, which is the equivalent of decimal number. So decimal equivalent of 200, its equivalent octal is 310. So going through the steps, we have to divide it by 8 and store the remainder. We have to continue this step until the decimal number is 0. The equivalent octal we get by reading the remainder in reverse order. Coming back to the coding portion, let us declare the variable decimal number as integer. This is the number from the user for which equivalent octal has to be calculated. Let us also declare the variable octal number and initialize it to 0. We will get the decimal number for which octal equivalent has to be calculated from the user through console. We are going to use scanf statement to read the input from the console and then store that input value into our variable decimal number. As we know, uh, to do the conversion from decimal to octal, we will start executing inside an while loop, and this while loop will be executed until the decimal number is not equal to 0. We have to store the remainder of the decimal number on dividing it by 8. So first we will get the remainder by doing modulus of 8. Now I will also declare the variable remainder, which will hold the remainder on dividing the decimal number by 8. As we saw before, 8 is the number of digits in octal, 0 to 7. In order to see if we are getting the correct remainder, let us print the remainder at each step of this while loop to our console. This remainder will be executed inside this while loop. So as many times the while loop is executed, we will get the remainder value. To exceed the while loop, the decimal number must be equal to 0. Hence, we will divide the decimal number by 8. As we can see, first we are getting the remainder using modulus operator. Then we are dividing the decimal number by 8. On executing, we will find the remainder for 200. And the remainder at first execution is 0, then 1, then 3. So we got the remainders. Now the octal equivalent of 200 is by reading the remainder in reverse order. So we will see how to store the remainder in such a way that we read the remainder in reverse order. For that, the remainder has to be shifted to the right position for every while loop of execution. So let us introduce another variable I. At every while loop, it will get multiplied by 10. I am also initializing I with 1 as we use it for multiplication. At the first time, when I is multiplied with remainder, the remainder will be in the unit position, that is a rightmost value of octal. At the next while loop, the remainder will get shifted to the second position because we are going to multiply by I, which has the value of 10. So each time the while loop is executed, the new remainder moves from rightmost end towards the leftmost end. With this statement, we are storing the remainder in the reverse order and hence reading the remainder as intended for the octal conversion. This is the important step to be noted for storing the remainder in the reverse order. So far we were printing the remainder only inside the while loop. Now on storing the remainder in the reverse order to the variable octal number, we have converted the decimal number to the octal value, and let us print the octal value to the console. Our compilation is successful. Let us provide 200 as the decimal for which octal is 310. So we have successfully stored the remainder 310. One more execution. I will provide 453, for which the equivalent octal is 705, and our C program has converted it successfully.